Okay, we defined what a buffer was. We said it's a solution that resists a change in pH, but we actually never explained how it does that. So let's just take acetic acid because that's an easy one to do. I'm going to have acetic acid and then I'm going to have my corresponding salt. There. That's a buffered system. Let's just say I've got 0.10 moles of this, and let's just say we got 0.100 moles of that. I'm dealing with moles in this case, not molarity. It's not a huge deal. So in my solution, I'm going to have this, and this, and this. I've got 0.100 moles of that. I got 0.100 moles of that. So what's going to happen when I add a base? Let's say I add sodium hydroxide, okay? And I will have some of this. I don't really care how much there is, but I will have some of that. We could calculate it if we wanted to, but we're not going to. So if I added a base, what's the base going to do? It's going to react with the acid, right? So that means there's going to be less of this, okay? Well, what does Le Chatelier's principle say? Le Chatelier's principle states that a system will adjust to counteract the stress. So in this case, the stress is that there's less acetic acid. Well, what's going to happen is my reaction is going to shift left. Okay? So that means I've got some of this conjugate base that's going to shift over here and make up for the amount of acetic acid that decreased. Okay? So by doing that, the pH doesn't change very much. Okay? Similarly, we can think of the other situation. What if we add an acid? Well, if we add acid, what's the acid going to react with? The acid is going to react with my conjugate base. So that means the amount of this is going to decrease. Well, what does Le Chatelier's principle state? Well, if the stress is this thing decreasing, well then my reaction is going to shift right to counteract that decrease. So it doesn't matter if I add a base or if I add an acid, the system will shift left or right to counteract that stress. That's how bases work.